right, Ethan, we're going to see if we can figure this out. I may need your help. I think that I'm doing this correctly, and if I talk this whole time and it disappears, I'm going to be really, really mad. Okay, so this is section 1-2 of the book, and I've got you the PDF of this textbook, so you don't have to buy it. I mean, you could look around and find one if you really want to own a paper copy or anything, but there's a PDF, is in Schoology, so you're good there. So, section, this symbol right here, like if you do this, that stands for section. It's just shorthand. And so section 1-2 means it's chapter 1, section 2 of this geometry book that we're going to use. So pretty much we're just going to get to it. And what's the best way to say that? I guess parts of geometry, there's really not a good definition for the main things in geometry, because they're so basic to everything else that it's hard to give a definition to. So here's what the 3 undefined terms of geometry are. It's a point, a line, and a plane. Okay, so that's your 3 biggies. And I know you're sitting here thinking, well, those are really simple. I already know what those are. But in geometry, it gets more in depth. So when you put a point on a sheet of paper, like say, here's 3 points, the dots are not actually the points. They just represent where a point would be. So like a point doesn't have any size. Let's start there. It has no size or dimension. You know, it's just a spot out in space somewhere. The points that you put on a sheet of paper represent where those are. Okay? It is the simplest, I guess we can say it represents the simplest geometric concept. Okay, so it's a location in space. So it's going to indicate position. Let's see. We represent it with a dot on paper. So represented with a dot. And you name them with capital letters. That is a non-negotiable. It has to be a capital letter. Okay? So, and that's, like if you're using one diagram, you would never have 2 different point Bs. That's very confusing. So now, diagram to diagram you could, as long as they weren't working in tandem. You wouldn't want to do that. All right, so point is an undefined term. Everything else is made up of points. So the second one is a line. Again, I know you know what a line looks like. You know, you've used them lots in the past. So, ooh, that's pretty straight for freehand it. Here's a line. It has an infinite number of points. It consists of an infinite number of points. Okay, extends forever in opposite directions. So I said forever a second ago, but I didn't write it, so we could put it goes on forever. That's really not a good mathematical way of saying that, but, and this one does have a dimension. A line is considered to be one-dimensional. All right, now naming a line. Let's say you've got this point right here, point A. You can't name that line point A because, you can't name that line A because here's another line that goes to point A. Like, which line are we talking about? So there's an infinite number of lines that go through point A. There's only one that's drawn on the paper. Okay? So to name a line, we're going to need a second point. So we could call this line AB. So to name a line, you need 2 points, 2 distinct points. and you put the line symbol on top. Now, it doesn't matter if you call it line AB or line BA. Nobody cares. It's going through B and through A and keeps on going forever. So it does not matter the order that you write them down. And then, like if I threw a third point in here, say I called it point C right there, then I could also call this line AC, or I could call it line CB, or what else? I could call it line BC, or I could call it line CA. Like all these are fine. You never name a line with more than is needed. So like you would never call this line ACB. Well, yeah, it's going to go through C because C is between A and B. So like you don't need to tell people that. So you just need two distinct points on the line in whatever order. Now, another thing that you'll see a lot is sometimes you'll have a little cursive lowercase letter out on the end of the line, and like that would say, okay, this is line K. And I don't really know why it's always in cursive, but it just always is. And then, so that is also an undefined term. Like it's hard to give a definition to a line because it's just such a basic idea, as is a plane. So planes are basically the word you always look for to see if people understand what a plane is if they use the word flat, they understand what a plane is. So a plane is just a flat surface. Now the difference between a flat surface and a plane, though, is like when you think of flat surface, you think of it as having an end, but the plane goes on forever. It's like a line, like it just goes on forever, like a plane does too. Like the top of our desks, those are planes, but anything that extends in that same plane in any direction would still be considered in that plane, the plane of the desk. You don't have to actually see it, just like the floor. You know, the floor is only so big in our classroom, but anything that would have lined up with that would be considered to be in that plane. So when you draw planes, what they'll do is they'll draw like a parallelogram shape, and then they'll do stuff like, and I've seen this actually cursive or not cursive, but most of the time it's cursive. Like there'll be a capital letter, and it'll be like, here's plain M, and that's like an M in cursive, or there's plain M. So like we could call this plain M. Let's say you put a line on here, and we're going to throw some points on it. Let's say this is point A, this is point B, this is point C, and way over here is point D. All right, so this is the most common way to name the plane. But there are other ways to name a plane. Actually, before we do the naming, we should probably keep on talking about what a plane is. Facts about it, like planes are considered two-dimensional because you can go two different directions. It consists of an infinite number of points. Remember, it's not just contained in any one spot, though, too. It goes on forever in two directions. Again, that's not a very mathematical way to say that, but it goes on forever in looks right. Two directions. And it has no edges, even though parts of the plane could. Like if you chop off and only consider one little section, like the top of the desk, we could think of the top of the desk as having edges, but the plane itself does not. So again, you're going to use capital letters. They could be in cursive. So if you see capital letters, you got to be careful. So capital letters could either mean a point or a plane. So you got to use some context clues sometimes. That's probably the reason most people, when they talk about a plane, they like to write the word plane out in front of it, because if I just saw capital M, like I would instantly think that's a point. So this is never a bad idea to write out in front of it. Okay. All right. So let's say you wanted to name this plane another way, and somebody was like, ooh, let's call it plane ABC. Now this is going to be hard to show on the iPad. This is one of those things like we do it in class, but like what I'm writing on this iPad screen, it is flat. And yes, points A, B, and C are all in that plane. But, and here's the part that it's going to be hard to, let's say I could put a plane that runs through here going up and down. So where, change this up, let's see. So I would be able to see like, it hits the plane and then it pops out the other side, even though technically, we'll shorten this one. So, like, it's running straight up and down. Like, when the floor hits the wall, okay, that's two planes coming together. The points on that seam where the line and the floor meet, yeah, all those points are in the floor, but all those points are also in the wall. So you can't name a point or name a plane by three collinear points because nobody would know what plane you're talking about. Of course, some people say, well, that's redundant. You don't need that. Obviously, I just drew this one. There's nothing obvious in geometry. Okay, like you always have to consider every possibility, which you're going to really love, I think, because you think about those anyway. So you cannot name it with three collinear points. However, if you take three non-collinear points, like say I take points A, C, and D, there is only one plane one flat surface that goes through those 3 points. So like we could call this plane ACD. We could call it plane, we could pick two others, BCD. Like there's lots of choices, but these have to be non-collinear points, which just means they don't line up. Okay? So that's the two ways. Either somebody gives you a name of the plane or you name it with three non-collinear points. All right, there's other important words in geometry, I guess terms. So space, that just means the set of all points. Not in a flat surface, not in a plane, just anywhere, all the points in the world. We call that space, okay? We already talked about this. So collinear points versus non-collinear, which we just brought up a second ago. So let's say you've got this, A, B, C, D. Points A, B, C, and D, those are collinear. You throw in point G up here, it is non-collinear with the rest of them. Now, you gotta be careful. Like if somebody said, are A and G collinear? Of course they are. There's a line that goes through them both. Like any 2 points are collinear. It doesn't have to be drawn in. So if that was kind of a trick question, not trick question, it's just a question that most people that aren't thinking about it correctly miss. Like if the question is, are these 2 points collinear? Like the answer is always yes. There's no way that you can't draw a line between 2 points. I don't care where they sit. So that's the difference there. We got coplanar points versus non-coplanar. All right, so let's say we've got a plane. And in that plane, we put 3 points, A, B, and C. Now, to show somebody that a line is not in the same plane, we'd have to do something like this. Like we'd say, okay, here's a line, and then I wouldn't be able to see this part on the drawing, but it would pop out the other side. That's how you show people that something is not in a plane with something else. So point D would be non-coplanar with points A, B, and C. However, like if I said, are points B, D, and C coplanar? Yep. Like there's a plane that could encompass the 3 of those. It just wouldn't be flat with the other one. So this is sort of another one of those where if I give you 3 distinct points and ask if they're coplanar, yep. So it's just there could be that 4th one that's not. Let's see what we got next. An intersection, that's the set. Oh, I guess we should put the definition right here. So collinear points are points all in one line. Coplanar points are points that are all in one plane. Okay, and then the intersection, that is the set of points in both, or it could be more than two, in both of two geometric figures. And again, it can be more than two, but usually we start out talking about like these two things intersect here. All right, so when you talk about stuff, like here's three ways of saying the same thing, and then we're going to draw a picture of it. So A is in line. Oh, I'm putting stuff in there. So that would represent a line. This would represent a point. So there's some line L that point A is in. Or you could say it's on it. I actually say on instead of in. I use that preposition more often. Or you can say line L passes through point A. So there's a picture that represents those three. Okay. Right here, we've got lines L and H. Okay, so there's a line L. There's a line H. And they intersect at point O. So either in or at. And then O is the intersection of those two lines. Okay. All right, this one, K. Now, the little cursive-y looking K, that's got to be a line. So this is line K and point P are in M. Well, the only way, remember, capital letters are either points or planes. So the only way a point is going to be in, a point can't be in another point. So M has to be a plane, P has to be the point. So say we're going to draw in, we're going to say, oh, that looked awful. Let's do it again. So here's line M, plane M. There's going to be line K in that plane. There's going to be some point P in that plane. So let's say here's point P. So line K, point P, all in M. Got it? So plane M contains point P and line K. Oh, got a new part. J, which it looks cursive, that's a line. J intersects M, the plane, at point P. So we only want it to intersect at point P, which means it can't be in the plane, because if we just drew some line in the plane, then the intersection of that line and that plane are all the points in that line. So we need it to run through the plane, and we're going to call that line J. So P is the intersection of J and M. Okay, so let's see what we get here. We've got a line XY, so let's just go ahead and draw this. So there's some line that's got 2 points on it. Well, infinite points, but the two we know the name of are X and Y. And then you want M and N to intersect in that line. You know what? I changed my mind. Because the only way, you got to figure out what those are. 2 points can't intersect in a line. 2 planes can. So let's draw, I have a hard time drawing things. So, okay, let's make one plane. And we'll call it M. And then we're going to run another plane through there. And when they hit each other, I need to make that, this is where I struggle a little. Here's where they're going to intersect, because I am not much of a drawer. Okay, so I wouldn't be able to see this part. And then this would be, I don't have to draw this in, but like say there's point X and here's point Y maybe. And then this plane right here, let's call it N. And I'm going to color it in so I can focus in on it a little bit. It's like this is plane N. So if that were to run through plane M, then that means, okay, how am I going to erase this without it? Okay, let's get rid of this. That means I wouldn't be able to see this part right here. What other I wouldn't be able to see, nope, that's it. Okay, so I think you've got the hang of what's going on there. Anything you can't see in a geometric shape or a geometric drawing, we did with dotted lines. You know it's there, but you can't see it. So that takes care of that. If you're like me, the hardest part for you is going to be drawing it. Like, understanding it, you're going to be fine. Drawing it takes some practice. And you may want to get, a geometry template. And I've got some, I just don't know where they are. I have a whole bunch of them, which you're more than welcome to have one. I just got to look for them and see if I can find them. Okay. But anyway, so here, dashes and diagrams. Oh, we just said that. Dashes and diagrams indicate the parts that are hidden from view. So, like you've got this line AB is running through plane P. So this little section right there, can't see it. So it's dotted. So this is a much better picture than anything I would be able to do. Let's see. In the textbook, okay, this one, in our book, they do something we just got to make note of. In our textbook, whenever the book refers to 2 points, like if they say 2 points or 3 lines, they automatically mean 2 different points or 2 different lines, which that's not necessarily always, like somebody can say 2 lines, and like, let me show you. So here's line AB. And then out here, and all 4 of those points end up being collinear. So somebody's talking about line GM and line AB. Those are the same line. Okay? So unless somebody gives you this, I guess, not notification, but somebody tells you, here's what I'm going to mean the entire year. Then if somebody says 2 lines, you shouldn't assume that they're 2 different lines. But I'm telling you now that anytime we talk about anything in the textbook, when they say 2 lines, they're going to mean 2 different lines, 2 distinct lines. 3 planes, they're going to mean 3 distinct planes. So you don't have to worry about that. But that's not the case on like standardized tests and stuff. You just got to be careful and, just make sure everything's all right. So true false questions. So we got plane, or actually, is it plane P? No, P is a point. So point P is in plane M. All right, so here's plane M. That's that flat surface. Point P is shown line on line, or plane N, but they're not the same plane. So this point down here can't be in that flat surface. So this is definitely a false statement. Okay. Uh-oh. Come on. All right, next one. Line B, where is it? There. Is in plane M. Yep, that's true. Okay, line XY, so this line right here, contains point P. No, they're in different planes. Well, I said that wrong. They are in the same plane. They're both in plane N. But, like, point P is not in plane M, and in line XY is. So there's no way one can be in the other. All right, plane M, so we're looking at this plane here, contains line XY. True. Got it? Okay. A is on B, so point A is on line B. True. Okay. All right. A and P are in M. Okay, so M is the plane. So we're looking at this plane. A is a point. That point is in line M. In plane M. P, though, is not. So because it said the word and, this one didn't, we got to say it's false. If it had been an or, it had been true. Okay, plane N. Let's see what we got. So here's plane N. Contains point P. True. And then A and P are collinear. They're 2 points. They have to be. Okay. So, there it is. Just because it's not drawn in doesn't mean it's not there. Okay? So I guess we should probably write that out. It doesn't have to be drawn. It just has to exist. let's see, intersections versus unions. You're going to be fine here because we talked about this in 8th grade. So an intersection, that's the symbol. And it goes along with the word and. A union symbol, remember, don't put the leg on it. It's not the letter U. That's a union symbol. And it's basically like the word or. So intersections are what you have in common. And the union symbol is what it is to be combined. So, like, I used to always give this example in geometry class. When my husband and I got married, we both had tons of CDs. And we had the Nirvana, I say the Nirvana CD, the first Nirvana CD that everybody had. Like, we both had that, so that would be an intersection of our collections. However, we had no reason to have 2 of those CDs. So when we listed out what all CDs we owned, we wouldn't have listed that twice. We would have just listed it once. So that's like a union. Like, the union of our CD collection is all of our CDs put together, but it's still, if we just inventory is not the right word, because in inventory you would say how many you had, but if you're just telling people what CDs you've got, you wouldn't list them. You wouldn't say, I have 72 of these. No, you have it. So that all comes into play here. So this one, we want B unioned with C. So we're going to look at B and C, and we're going to just take and make a set where you put all those together. And let's put them in numerical order so we can keep up with them better. There's a -2. There's a -1. There's a 1 and a 2. There's a 2 over here also. I don't need to list it again. And a 4 and a 6 and an 8. So that's the union of those 2. Now the intersection, what's the one they had in common? 2. So the intersection is just a set with a single entry in it. Okay? All right, so now let's look at A and B. Okay, so we're looking at this one and this one. We want the intersection. Okay, this one's got odds, this one's got evens. They don't have anything in common. So we would say that the intersection of that is the empty set. Some people call it the null set. Some people actually draw a set and leave it empty. That's another way of doing that. If you wanted the intersection, let's see, that's the intersection. I meant union. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be a set that contained these 9 whole numbers. Okay. All right. So next one, we're going to do this part first. We want A union with B. All right. Oh, wait, what did I just, oh my gosh. Ethan, I hope you didn't write this down. I hope you were paying better attention than I was. I thought it was going to do A, B. A union with C. Okay. Let's try that one more time. So A union with C would be, all right, what all is in there? Come on, pen. Oh, because it's still set as a highlighter. Okay. So we'd have -2, -1, 1's in both of them, 2's over there in C, and then 3, 5, 7, and 9. All right. Well, this is where I noticed I'd made a mistake. We're going to do A union with B, which we already talked about. So it's taking A and B and just combine them all together. So that would be this set here. And then we're going to intersect that with this set. Whoop. So it's just saying, what do they have in common then? They both have a 1 and they both have a 2. So that would be the set 1, 2. Or the set that contains 1, 2. All right, now we can do geometric intersections and unions too. So name 2 points that are not on line AE. Okay, so not on here would be H and R. Okay, now that didn't run off very well. Okay, this is a line and this is a line. For some reason they didn't show up great here. Okay, but it says find AG. So I'm going to do yellow and blue because yellow and blue make green. So line AG, that's this line. Line HR is this line. So where's the place where they intersect? It's that one little spot right there where they came together. It'd be point U. Okay. Next one, name a point on line AB, but not on line AC. Okay, so on AB, but not AC. Well, that's got to be point B. Okay. Name the point that's on both line AB and AC. Well, that's going to be A. That's going to be their intersection. All right, so now let's think about what this is. P is the plane. D is a point based on this picture. So we're taking plane P, intersecting it with point D. Well, point D is inside plane P, so the intersections would be point D. All right, next up, line AB union with point P. Okay, so let's take AB, this line, and put it together with oops, I wanted to change colors, with everything in point P. Well, line AB is part of point P, so if we union them together, if we combine them together, we're just talking about plane P. So it's kind of like the intersection of these geometric figures. Think of it as when you paint, the intersection will be the part that you paint both colors. The union is just anything that's got some paint on. I think that's a good way to think about it. So next up, line AC. Okay, so line AC. There's that line. Intersecting plane P. What do they have in common? Well, everything on line AC. And then name a point that's on neither line AC nor AB. Well, the only thing that could be is point D up there. All right, and then here's just a new diagram. Name 3 points in plane Q. Well, we got lots of options. We could do RS and T, that would work. You know, RS and V, RS and W, any of these would be okay. So, for example, our points RS and T coplanar. Don't even have to look at the picture. Any 3 distinct points are coplanar. So, yes, definitely. Our points R, S, and T collinear. No, T is not on the same line as R and S. So, no. All right, let's do another union and intersection. So, we're going to take line UW. Okay, so we're looking at this line here. Intersecting point, not point, hang on. So, this line intersecting plane Q. So where does it run through? Right there at point W. And then does UW, does that line lie in plane Q? No. One point of it does, but not the whole line. And then find the intersection of line UW and line RS. Well, there's not one. So that's the empty set. Okay. Use the diagram below to answer questions 15 through 18. Let's see what we have here. We're going to answer true or false. So this picture, points A, K, and N are collinear. That'd be true. Oh, and the best thing you can do, like when you're taking these notes, like I want you to listen to the whole video and all that kind of stuff. But when you get to stuff like this, the best thing to do is just pause it and you try to answer them first, and then you listen to me and see if you got them right. Okay, just like we do in class. So points K, N, and E are collinear. No, so that's false. They would be coplanar though. A and I are collinear. Again, I don't even have to look at the picture. Any 2 points are collinear. You know, it doesn't matter if it's drawn in or not. There's a line through those. And then I, K, and E, I don't care if, oh wait. Ooh, this brings up a good point. We don't need to ever assume anything in geometry. Well, in life and math in general, but especially in geometry. You can't just go, well, they look like they line up, kind of. Unless you draw a line through there and tell me for sure that they line up, don't tell me they're collinear. Okay? All right, so again, right here, stop the video, try these, and then check your answers. So let's go through here. Name a point not in plane NRS. Okay, plane NRS. So that's plane Q. Some point not in plane Q. I could say B. Or I could have said A or C. All right, name a point. Actually, I probably should just say B. Because what if A were sitting in a spot where it could line up with plane Q? I mean, it's possible. All right, so name a point not in plane BRS. So a point not in plane P. So anything not in this one. So I could say either A or C. For sure. I know it would be right. Name 2 points in planes P and Q. Okay, so P and Q run together at this line right here. So any 2 points on that line. So S and R. And then name 2 points not on line SR. So N, I could throw that on there. And B. All right, plane P intersects plane Q in line RS. And then line SR is union with plane P. So it's all contained in P. So when you throw them all together, that's just plane P. Then R intersecting Q. Okay, something. R is a point. Q is a plane. What do they have in common is point R, because R is in Q. Line AC. Oops. Why is it? Come on. Don't be aggravating. Yeah. Well, it worked right there. Maybe I just didn't have it far enough. Okay. AC, where's that? All right, got that line running through plane P, intersecting plane P right there at point B. Okay, all right. Oh, we're almost done. We're getting close. Again, stop it, try these. All points on a line are collinear. Yeah, that's the definition of being collinear. All points in a plane are collinear. No. And so we're going to draw a picture that illustrates this. So here's plane. You take all the points on there. Like, here's a line, but those points aren't in it. Okay? All the points in a plane are coplanar. Duh. That is the definition of coplanar. Any 3 points are collinear. No. Any 2 points are. But you throw that third one in, you might not be. And also, I want you to think about this. This is the reason why tables at restaurants are off balance. You know, like when you're sitting in a restaurant and the table wobbles and you have to put like sugar packets under a leg. You never have to put the sugar packets under more than one leg, because the three other legs, think of the bottoms of those legs. Those are points in space. Those are 3 non-collinear points. They define the plane. It's when you throw that fourth leg in where it might not be in the same plane. And that's why you just have to put the sugar or folded up napkins or whatever you're doing. You only have to put it under that one leg. So technically, if we just had 3-legged tables all the time, our tables would never wobble. So I have yet to understand why we don't build 3-legged tables. So any 3 points are coplanar. Absolutely. Okay. And listen to this. 3 non-collinear points determine a plane. If you had 3 collinear points, they don't determine a plane. By that, I mean designate the one and only one plane we're talking about, because there are infinitely many planes. It might be the flat surface like the iPad screen. It might be the one running up and down. You could tilt it a little. I mean, like, there's all sorts of, this is a horrible drawing, but I think you get what I'm saying. Like, you wouldn't know exactly what plane you're talking about, but it's still going to be in a plane. And then 2 intersecting lines are coplanar. So let's think about this. Here's one line. Here's the other. And when they intersect, 1, 2, 3, you can form the 3 non-collinear points that will determine a plane. So this has to be a true statement. Okay, and then what's the minimum number of points required to determine a line? 2 distinct ones. Okay, how many points are on a line? Infinitely many. What's the minimum number of points required to determine a plane, and what must be said about those 3 points? To determine a plane, you have to have 3 non-collinear points. Okay, so our textbook authors state 3 ways to determine a plane. 3 distinct non-collinear points, a line and a point not on the line, 2 distinct intersecting lines. And it says, personally, I feel like the second 3 ways. I said that wrong. Okay. I think you just need to say this one. 3 distinct non-collinear points determine your plane. A line and a point not on the line, that's 3 non-collinear points. 2 distinct intersecting lines, I can find 3 non-collinear points. That should say the second 2 ways. Well, no, it should. Let's say, I feel like let's say the last 2 ways are redundant. Do you see why I feel that way? So this takes care of it. We're good. Find me 3 distinct non-collinear points. We've determined ourselves a plane. All right, so here is your homework. We're going to do section 1, 2 out of the book. And again, you've got a PDF. WE stands for written exercises. So let me look. I haven't used this book since 2021. I forget what the other ones are called. So there's going to be, let me just find some random. Okay, so there's classroom exercises and written exercises. Make sure that you're doing the written exercises. And then here are the answers. So don't look at those like as you do them, but check them as you go along and make sure that everything's making sense. And now I have to stop this video and see if I can figure out how to get it to Schoology. So, I mean, I got one part of it done. I'm feeling pretty good about this, but we'll see if I can do the rest.